This is section 4.3 from Masses to Balanced Equations. In this tutorial, we will learn how to balance an equation given the masses of reactants and the products. So if we have the mass of all reactants and the products, how can we balance the equation? Let's start with this example. Sodium nitrate, whose chemical formula is NaNO3, decomposes on heating to give sodium nitrite NaNO2 and oxygen gas. So sodium nitrate will decompose on heating. So when sodium nitrate is heated, it will break down to produce sodium nitrite and oxygen. This is a decomposition reaction. When 8.5 grams of sodium nitrate is heated in a test tube until its mass is constant, 6.9 grams of sodium nitrite is produced. So we will heat 8.5 grams of NaNO3 in a test tube, and we will find that the mass of sodium nitrite produced is 6.9 grams. What mass of oxygen must have been given off in the reaction? First of all, let's start with writing the word equation for this reaction. So sodium nitrate will decompose to produce, so the reactant is sodium nitrate, and the products will be sodium nitrite and oxygen. We are given the mass of sodium nitrate, which is 8.5 grams. And the mass of sodium nitrite is 6.9 grams. In previous lessons, we learned about the law of conservation of mass, which states that the mass of the reactants must be equal to the mass of the products. So the mass of one of the products, which is oxygen, is unknown. Let's call it X. So X is the mass of oxygen gas produced. According to the law of conservation of mass, the mass of sodium nitrate must be equal to the mass of sodium nitrite plus the mass of oxygen. So 8.5 grams is equal to 6.9 grams plus X. Now this is a mathematical equation that we can solve. X is equal to 8.5 minus 6.9, which is equal to 1.6 grams. So the mass of oxygen gas produced is 1.6 grams.